How's it, guys? Welcome back for another edition on this channel. Today we are starting a new topic, which is logarithms, and we are gonna start with explaining the laws, the laws that govern logarithms. So, in this video, I will focus on the first four. As you can see there are about six of them. So I'll focus on the first four. Then in the second part of the video, I'll explain the last two. Okay. So to begin with, what exactly is logarithms? Okay, a logarithm in layman's terms is just uh, is just the inverse the inverse and this is very important, guys. The inverse of uh, exponent. Let's see here. So basically, this is the easiest way of understanding logarithms, because it's just as simple as that. The inverse of exponentials. So what are exponentials or exponents? Exponents are just when we have a number, let's say n, that has to multiply itself, let's say 5 times. So basically, we make it in simple terms to say n to the power of 1, 2, 3, 4. We have four n's there, to the power of 4. This is an exponential. So that's simply what it is. So what it relates to logarithms is that if then in exponential terms, if then x is equal to let's say a to the power of n, let's say m, let's use m then. Therefore, if we reverse this to turn it into a logarithm, then we would say the logarithm to the base of a of, let's say, of x will be equal to m. Now, do you see how that is related? So it's just vice versa. So when you work out exponentials, you can actually introduce logarithms, and when you do logarithms to prove the formulas, as you're gonna see as we go that to prove the formulas of logarithms, the laws, we actually introduce uh, this this exponential, x is equal to a to the power of m, into the logarithm for us to end up with the final answer. Okay, so guys, we are gonna begin with law number one. Law number one says log a, it's log a, law one, it's log a, let's see, it's just log 1 is equal to 0. log 1 is equal to 0. What this is saying is simply saying that if we are going to say a to the power of 0 is equal to 1, because any number to the power of 0 is 1, whether be it a million to the power of 0 is 1. So this is what this law is actually saying. Then law number 2, so bear this in mind, that if the question is asking you to find the log of 1 to any base, then you must definitely know that the answer is 0. Then law number 2, we say log a log to the base of a is equal to 1. So it's log a log to the base of a is equal to 1. What it's simply saying is, in exponential terms, we are saying a to the power of 1 is equal to a, which makes sense in a way that any value 2 to the power of 1 remains 2, and 100 to the power of 1 remains 100. So any logarithm to a number that has the same value as the base, then that number, that the answer is 1, as you can see there. Okay, so let's go to law number 3. Law number 3. Okay, there things get a bit tricky. Yeah, gets a bit tricky there. Let's see. So we have log a log to the base of a of x multiplied by y. Log, okay, so it's log to the base of a of x multiplied by y. Okay, thus of course this is equal to log to the base of a of x plus log to the base of a of y. That's simply what it says and what it is. So let's do some calculations there, some playing around with this x and y and a and m's and n, so that we prove that log to the base of a of x multiplied by y equals to that. So our first step, what do we have to do? We're going to write our expressions in exponential format, which will be our x there. Our x will be equal to our base, which is a, to the power of, let's say, m. Then our y is equal to a to the power of n. So basically m and n represents the the result, the answer that we get um, if we get the logarithm to the base of a of x, then we get that m. If it's x, then y. In terms of y, we get n. So our second step here, this is step number one. Then our second step here, we are gonna have to substitute that into our logarithm, which is log a, our bracket. So x is equal to n to the power of m. So n to the power of m, then multiplied by a to the power of n. Then step number 3, logarithm of a. We see our base is the same there, and we're multiplying, so our powers, they add. I'm sure everyone is aware of that. We have to add our powers, which is m plus n, and then number 4, and then now we know that we have that expression now. Now we need to substitute our logarithm expression, our logarithm expression of x is equal to a to the power of m. If we turn that, okay, let's say x is equal to a to the power of m. If we put that in logarithms terms, it will be equal to the logarithm to the base of a of x is equal to m, right? The same with y, be equal to a to the power of n. In logarithm terms, this would be log to the base of a of x be equal to n. Therefore, we now substitute there. We have log to the base of a, we have log to the base of a to the power of m plus n. Therefore, if we substitute there our logarithm expressions there, we are going to get log to the base of a, then our a to the power of the value of m. You see there, m is log a, is log to the base of a of x, so which is log to the power of log to the base of a of x, then plus, what is our n? Our n is here. Here's our n. N is log to the base of a of y. It's supposed to be y here, guys. Sorry about that. It's supposed to be y here, which is log to the base of a of y right? Here we go. Now we have our expression there, and then this is a log to the base of a of this. But now, at the same time, our a, okay guys, as we can see now that we have a log to the base of a of a to the power of log a log to the base of a of x plus log a log to the base of a of y. So now, using law number, should be number 5. I know we haven't done that as yet, so let's just have a look. Law number 5, as you can see there, this one. Law number 5, it says that log to the base of a of x to the power of b. So our power becomes the coefficient of the log, and then the rest of the expression remains the same. So if we come back here, we're going to apply law number 5 to say, here is our power. It's raised to the power of, we're going to make it the coefficient, which is log to the base of a x plus log to the base of a of y. Then this should be in brackets. Then we are left with log of a. And remember that this log a, if we have the same value, the log of a number with the same base, which is a and a there, it takes us to the first law, which is what? Law number 1, law number 2 as such, rather. You see there? Is equal to 1. So we are saying log to the base of a is equal to 1. That's the same thing here. That's the same thing. So which means we will have log a to the base of a of x plus log to the base of a of y multiplied by 1. I hope you understand. And you should know that anything multiplied by 1 remains the same. So our answer would be log to the base of a of x plus our log to the base of a y. So that's how you prove, this is how you prove our first, the third law, which is this one. That's how you prove it. Okay guys, we are going to do the law number 4 in the next video, because yeah, we spend a little bit of time. We already did 3, so if there's still time in our next video, we'll cover the last 3 that are left. So guys, stay tuned, and don't forget to subscribe, hit the notification button, drop any comments. If you have any questions, feel free to ask. If you need assistance in anything that has to do with math, accounting, and finance, feel free to post your questions, your queries, and etc. Okay, guys, stay blessed.